very pleased to introduce Sasha Gruszczyk, the CEO and director of NowVertical. Sasha is an experienced technology leader, having run operations with over 200 million revenues and over 1,500 employees. But he also brings a rich history with startups and with M&A experience. With respect to Now, we are very bullish towards the company's foundational fusion technology and data analytics. We believe these represent a foundational layer to leverage IP-based commercial AI applications. Now, not wanting to steal your thunder, Sasha, in any way, but I encourage everyone to watch the presentation. And there's one slide, a graphic depicting Now's technology partnerships. It's really impressive to see what Sasha and his team have done to date. And it also gives you a tremendous roadmap looking ahead. So with that, I'm very pleased to hand it over to you, Sasha. Sasha, thank you.
So thanks everybody for the time. What a great conference. Applied AI, couldn't agree more with the subject matter and get more excited about it. So hi, my name's Sasha. I'm the CEO of NowVertical. I've been the CEO for coming on 60 days, but I've been with the company for about 18 months, which is 3/4 of its history as an organization. So who we are and what we do really boils down to this, which is we're really looking to create smarter, faster, and better connected companies and governments with artificial intelligence. Smarter in that we want machines to do things that people can't. Faster, that we want to move the speed of data. And better connected is that we want to bring our customers closer to their clients and customers and stakeholders. So we're really looking at the deployment of artificial intelligence in these arenas. Huge numbers. I think that the latest data on the impact of AI from a kind of a economic growth perspective are enormous. But when I get really excited is when I take a look at the chart on the right-hand side, which is looking at organizations in some of the leading countries in the world that are either deploying or exploring AI. And you see massive levels of penetration in and around this space, which tells us that the market opportunity is quite large. When you dig a little bit deeper into what does it mean to do artificial intelligence with governments or companies or large enterprises, is that there's 4 big barriers to any type of success there. The first is data. Most organizations and governments have no idea where their data is, what it represents, whether it's secure at all. The second is around talent. We're in a huge position of talent scarcity right now, especially as it relates to data science and any type of applied AI. The third is around risk. You cannot overstate the risk in the way in which that AI is deployed in enterprise and in governments, specifically from the viability of the data, the bias in the model, the interpretability of the model, or even the risk associated with the data that gets imported into those models. And the final piece is around returns, right? So we ultimately don't want to be in the science experiment business. We want to be focused on outcomes for our customers that are going to generate material returns in the work that we do. So when we talk about smarter, faster, and better connected companies and governments, we're really targeting the way in which that they do the things that they do. So how do we actually deliver AI in industry and in government? Well, it really comes down to the confluence of kind of 3 critical inputs in terms of the work product that you ultimately need to generate. The first is around the kind of data governance, engineering, and infrastructure, a highly underestimated scope of requirements to build artificial intelligence models on top of existing operations. One important distinction that I always like to make is that unlike the general training data sets that a lot of these kind of new AI companies are built upon, most organizations and governments will not be using generalized data sets in order to deploy AI in their workforce or in their workplace, because it's non-specific, it's generic, and it's not representative of the way in which that they work. So you have to do the work around the governance and engineering and infrastructure piece to be successful. Part of the reason why we talk about our partnerships with Amazon, Microsoft, Snowflake, Google, and Qlik is that the penetration of these companies in our global kind of customer base is quite high, and they have some of the critical tools and technologies that enable for AI to be built, but they're not exclusively within those arenas and environments. The second piece is you really need to bring data science and analytics to the table to get you some sort of benchmark as to what you're trying to use AI to improve upon. And the final piece is around ML and AI. And I really liked the categorization that Rob offered around computer vision, natural language processing, knowledge graphs and networks, as well as robotics and automation. This really speaks to the vertical intelligence focus that we have as an organization, because AI doesn't mean the same thing to every company, just like a bank doesn't work the same way as an auto manufacturer as a retailer does. So the famous slide that Rob Goff talked about is about our vertical intelligence operating system, which is the way in which that we orchestrate all of our customers' environments and data into a machine learning environment that enables us to build these solutions. This is early stages for us in how we integrate our acquired technologies, but it's a really powerful way in which to bring artificial intelligence solutions into an operating environment, whether it's a customer that's a Fortune 1000 or a large government. This is how we make money. We have technology services and consulting. We sell through our own proprietary technology, and then we work to sell through third-party technologies. When you look at the modern AI environment for enterprise and government, you really have to be modular. You can't look at a one-size-fits-all. No organization, no large IT team or infrastructure is going to say, we're going to go all in on one technology. Never happens. So you have to be flexible and modular. And that's the way in which that we're building our organization. So rather than talk in generalities, let's talk about some specific use cases. So I'm going to do this, maybe the second or third hardest thing here is I'm going to try to share a live demo. We just launched a partnership with Azure OpenAI, which is the enterprise-grade OpenAI models and systems for companies that are looking to deploy large language model capabilities into an enterprise setting or a government setting without moving their data. So this is totally secure. There's no data leakage. There's no risk. And we're doing work with some of our customers. And this is one of our early customers. It's a customer that we do a lot of customer service work with and customer service reporting with. So Blinds to Go, large custom blinds manufacturer out of the UK. And we do a lot of data science and data visualization work with them. So what we've done here is we've deployed OpenAI's large language model across their inbound customer service center. So this is their customer service email inbox that gets serviced across the variety of different customers. So we just started this work in July because we just announced the partnership in July. And so this is just a very basic visualization of the inbound customer service requests that you get. But what's really cool when you start to dig down here is that the way in which that we built this is, yes, we had to do some data engineering to get all the data in the right form and format for the large language model to ingest. But everything that you see here in the categories was entirely generatively built. So none of this stuff was pre-programmed, and none of this analysis was done by humans. This was done entirely by the large language model. So the way in which that the LLM works is that it takes all the data and it starts to build you these custom profiles and breakdowns of all the email inbound topics and starts to do some generative analysis. So what do we mean specifically by that? So these categories that it's generating here, right? So these are all generated by the large language model. No human has touched this. So if I click on complaints, it's categorized these 4 emails as complaints. And what's really cool, and maybe slightly nerdy for us that work in the space, is that sentiment is always a really difficult challenge to interpret with machines because it relies on natural language process. So the simplified version of this is machines are really bad at knowing the difference between something is bad and something is badass. So oftentimes they struggle interpreting which is which. But when we look at this deployment and it starts to do some sentiment analysis across an email, and this is a unique email and that I've obviously not pre-programmed, but you can start to, what the language model is doing is reading the email and it's assigning some sentiment analysis to it, right? So you're seeing things like issues still with my order, overlaps, has hinges attached to both sides, see the picture. I think you need to refund the full amount and call it a day. Excuse me. So obviously a negative sentiment. But if we take a look at something like this, which has a positive sentiment, you can start to see that there's a lot more positive a sentiment associated with it. So we can also use machine learning to determine customer churn. So in this instance, we worked with the Commercial Bank of China to determine what the churn is going to look like using gaps in the data sets that was available. So in this instance, we used sophisticated machine learning models to determine and identify churn that improved the churn prediction by over 15%, which is huge in commercial banking, and was able to target specific retention activities, excuse me, to support the retention of those customers. So again, really focusing in on outcomes for our customers with the deployment of AI. Another example is work that we've done with The Economist. So again, using machine learning and data orchestration to get improvements in subscriber growth, subscription revenues, and overall operating profits. And this is really just about using machine learning and artificial intelligence to optimize for these functions. So by bringing all their data together and starting to connect them through our different technologies and third-party technologies, we're able to start to generate these positive returns using ML. Huge problem in telecommunications actually has to do with pay-as-you-go churn or pay-as-you-go customers. Because you don't have customer data or a history of customers with pay-as-you-go, it's really difficult to determine how those customers are going to churn. So what we were able to do is using some advanced algorithms, we were able to start to predict when customers are likely to churn in the absence of knowing who they are, where they live, what they do. It's just based on stuff like location, their consumption data, and where they purchased it. So by reducing churn by 60%, we improved huge yields for our telecommunications customer in Liberty, Latin America. One of our final case studies here is just in around optimizing marketing spend. So Vitamin Shop had some existing models that were human built, and this was just to determine where they should be investing across particular direct mail activity. In this instance, we used machine learning algorithms to see if we could do some improvements and generated $2.8 million of additional revenue. In summary, we're really focused on trying to help and create smarter, faster, and better connected companies and governments using AI. And we're really focused on doing this on an industrial scale and service large organizations and governments around the world. We've got 250 customers currently across 5 continents, and that's about it. So I'm going to stop there, and hopefully we'll stop coughing for the Q&A a little bit later today.
Sasha, our thanks.